Hey, hi everybody. Everybody can hear me and see me? Yes, good. So let's share the presentation. So this is my first video, and I'm gonna talk about ARCore and Sceneform on Android. You'll learn how to build a ship in AR. So my name is Julien Salvi. I'm an Android engineer at Innovorder, a French startup in Paris. I'm developing Android apps since 2011 when Froyo was live. There were no fragments at this time. I'm part of the Paris Android user group. I love punk and metal music, and I often drink IPAs. You can find me in Twitter at Julien Salvi. So let's see what you're gonna learn today. So I'll be talking a bit about augmented reality on mobile. And then we'll see how it works with ARCore and Sceneform on Android. You'll learn the basics of these libraries. And then you'll see what you can do with ARCore, when you can do more with this library. And then we'll finish with a bit of game engine. So we'll see how to build AR apps with Unity for Android. So augmented reality on Android, as I call, like real reality with more fun. Here is an interesting number. We are almost 1 billion users of AR, of augmented reality, across the world. So it's a very big number. So augmented reality it's very accessible now with a lot of powerful devices across the world. Also, AR has many fields to work with. So you can build apps, for example, for housing and real estate, like the IKEA app, where you can place some chairs, sofas, and you can like imagine what your house gonna looks like. Also for gaming and leisure, obviously the famous Pokemon Go application. Also for science, education, or industry. For example, here you can learn how to learn Italian with science. This is a nice application. And also a new way to enjoy sport with a lot of metrics, a lot of analytics during the game. It's pretty much a very good improvement to add AR to sports. Also, you can like enhance your daily life. So, like here using Maps, the augmented reality version of Google Maps. So it's pretty nice to like guide yourself in the city with this feature. But you have to build AR apps, obviously, for fun. So on Android, there's many ways to build AR application. Obviously, you can use ARCore, what I'll be talking today. You can use Vuforia. It's there for quite a long time. You can use it on Android and Unity. You can use Wikitude, or you can use ARToolkit, which is open source. So let's talk a bit mostly about ARCore and Sceneform. So ARCore project started in 2017. It's built by Google, and Sceneform came a bit after in 2018. There's a lot of features like motion tracking, environmental understanding, and light estimation, which is the basics for building our apps, like wall recognition to place your objects and interact with them. with a nice feature with Sceneform, you can bring Android UI to AR, so you can very easily build some nice UI in AR, like you used to it in your Android application. And there's more than 200 Android devices supported, so now you can like have a great experience and a global experience with ARCore and Sceneform. You can reach a lot of users. So let's now draw some ships in AR. So the first steps. So you're going to learn the basics of ARCore and Sceneform library. You'll be able to display some basic shapes and 3D assets. You'll use also the Android UI components to interact with your assets. And we're going to use some nice animation to bring your assets to life. So our first ship will be him. Well, there's a ship in this box. And then you learn how to build this nice little ship with the basic shapes of Sceneform, like basically using a cylinder and a sphere. And then you learn how to like add some like more complex assets within your ARCore scene. So what about ARCore and Sceneform? The mean SDK is 24. If you want to use if you want to build an AR app only, but if you want to add some AR feature to your Android application, if it's optional, you can set the minimum to 14. OpenGL 3 is required to play some AR stuff in your application. And also you have to download the Google Plus FHC for AR on your devices, so you can use Sceneform and ARCore. And then if you want to use Sceneform, you have to target Java 8. What will be the Android manifest of your application? You have to have, obviously, a camera in your device, target OpenGL 3, and then notify that ARCore is required on the manifest if it's a IR only application. Then about ARCore on Gradle, so you can add the Maven dependency for all the version till 1.15, but the latest version 1.16 is no more available on Maven due to the open sourcing of this library. I'll talk a bit later about that. So for the 1.15, you can just add your Gradle dependencies, the ARCore and the ARCore and the Sceneform library. Just two dependencies to play with your app. So for now, I do not recommend to upgrade to the 1.16 version of the library. As Sceneform is now open source, the SFV assets, so all the assets generated by Sceneform and ARCore are now deprecated. So you cannot import new assets with the new version of the library and the new version of Android Studio, the 3.6. The Android plugin is not working anymore, and you have to use only GLTF assets. So all my example here will be based on the 1.15 version of the library. So let's do our first steps into the AR world. So in your activity, you have your fragment of your activity, and you have to add the ARFragment from Sceneform. This will be your AR scene. This is where you will have the camera footage, and all your assets will be rendered in this fragment. So just to access your fragment from your activity, you can check if the device is supporting or not, and then this is with data binding, and then you find your fragment, other ARFragment, and then you can play with it. So here's your ARFragment from your activity. So as you know, we are in a 3D world. So you have to think you are in the 3D world when coding our stuff. So you're using vector 3, which is a 3-dimension vector. This will be all the math for position, translation, scaling. So you got to think about the 3D vector. Another nice mathematical concept is the quaternion. I won't dig on that now. It's like a 4-dimension vector, and it's very useful for rotation computations, especially in the 3D world, in 3D math. And we are using the right-handed coordinate system. So as you can see on the scheme, you can have your right hand. So the thumb in the X, your index is the Y, and the Z is the other finger. I don't remember the name in English. Okay. So this is the coordinate system we are using here in ARCore. Then you will have to load some texture to have some nice assets. You can load some color from our RGB color. You can add some transparent colors if you want to. And also you can have some image texture for a very nice rendering. So here we are using like a cardboard texture to see how our box is like. So there is also 3 different shapes available from the shape factory. You have a cube, you have a sphere, and you have a cylinder. So every shape can accept a material which is the texture we loaded before, so a color or an image. And for adding this to the scene, you must provide a center, a radius, or a size, depends on the material you want to build and the shape you want to build. So let's see how to make this nice cube. So it's pretty easy. You can just use the material factory method, make opaque with color, inject your color, and then it's all asynchronous. You'll get your material at a point, and then you can create your renderable with the shape factory. For example, here I have all metrics are in meter, so it's like a 20 centimeter cube here, and with a bit of elevation. So same thing for the transparent cube. I make it with a transparent color, and then same thing with the color, with the texture. So we have our cube here with our texture. You can load it here. You can accept bitmaps. You can load from the resources, and then once it's loaded, inject it in your renderer. So, and then once your renderable is ready, you can add the set on tap plane listener to your ArFragment, which will detect the click on the environment. If your renderable is ready, we'll add the anchor. This describes a fixed location. The orientation is the real world. This is your base for your scene. And then we'll add a node. Here is a transformable node, so you can scale it. You can add some. You can place it on the scene wherever you want, or you can make some rotation with your fingers. So when the render is ready, I add it to the anchor and set the renderable, and then ta-da! You just have drawn 3 ships in boxes. So let's see some boxes in the real world. So here is a plain cube. Here our texture cube, another texture cube, and here I can add some transparent cube. Add a bit more. So it's cool, but you can do better, and you can work with the shapes, do much more nice stuff, playing with the basic shapes. And so let's see how to build a more realistic shape. So using the basic shapes, at least like 10 shapes, you can build like a nice shape, like almost realistic, just using one color and a wool texture. You'll learn how to compose with nodes, as I explained just before. And we'll learn also how to display Android UI in an AR world. And at the end, we'll use some nice animation, like to bring life to the chip. So in your scene, you have to think with nodes. It's a graph. It's like a tree. So a node represents a transformation within the graph hierarchy. You have first your anchor, and then all the nodes that have at least only one renderable. A node can have only one parent and 0 to n child nodes. You have to keep in mind this graph hierarchy in order like to add some nice animation or build your own AR scene. So this is the graph hierarchy of our ship. There is like some pattern on the right to see how it's gonna looks like. So you have your ship node with the ship in general, and then you have the 4 legs, the main body, the big part, which have 4 body parts for the wool. And then you have your the ship head with the left ear and the right ear. So this is the graph for building our ship. Now you have your graph hierarchy in mind. Let's see how you can add the different parts of the ship in the AR scene. So let's create the main anchor and the main node, the chip node. And then, for example, here, let's add the 4 legs. So we have all the position of the 4 legs. We have our leg renderable, which are cylinders, and then for each renderable, you have to construct a node which contains the renderable of the leg renderable and the leg position, and set the parent to that chip node. And after adding the other part and constructing the ship, you have at last your ship. So in the code, it looks like this. So creating the ship here, so you're creating your main node, adding the legs, then adding the body parts, which you're gonna place at different position to already looks like a ship. And then you can set the head. Then yeah, then the ship will be available in the AR scene. And you can even take selfies with him. So that's one of the advantages of using AR. So have fun. But we can do more. Let's see how we can display Android UI. So basically, you can do as usual, building your XML layouts. Using coordinate layout, frame layout, anything you want from the Android UI component. You are very free to use everything that's available. And then even all the view interaction are working as usual. So you can add your on-click, your recycle view, the unchecked, for example. Everything which is available on your Android side, you can use it in AR. So once you have your layout, it's very easy to add it to your node and do your graph hierarchy. Just here, for example, I just set the position just above the sheet, make a small rotation to be in front of us. And then I build the renderable of the Android UI component, which accept the layout resources. And then you can inject it in your renderable. And to access some views, you can get renderable the view, and here do what you have to do with the views, like click listener, setting the data, and so on. And here is the layout in AR. So let's see how it looks like in AR. And here is our ship, and then just I set a tap listener on the ship, and then you can have the card above the ship, which is a pure Android UI. Now let's add some nice animation to this ship. So we're gonna use Vector3 and Quaternion to do some nice animation. We're gonna play with position, scale, and rotation. For our animation, we'll only use position and rotation. If you are using animation on the Android side, we are using the same here. We are using Object Animator for animating nodes. And of course, you can compose animation with the animation sets. So you can play animations at the same time. So as I am metal lover, let's create a head banging animation. So here we are creating a head rotation animation for the head. So it's in green, the green rotation. So we are using the property name, so the local rotation, which will accept the quaternion evaluator. It's pretty much very similar to the Android stuff using Object Animator. And of course, we are also adding a bit of translation for the head on the y-axis. Then using the animation set, we are composing this animation to play the translation and the rotation at the same time. So for the rotation, I use like a bit of math to add a new like a new axis when I want to rotate. And then let's see the animation live. So here is our ship. Now let's play the ending animation. Moving forward and backward and forward. So here is the head ending animation, like a metal ship. And that's it. Like now you're ready to do some amazing stuff with the basics of ARCore and Sceneform. But let's play now with like real 3D assets, more complex with 3D assets. So I recommend you to use GLTF format even for the future if you want to import some very complex assets. Before Sceneform 1.16, you were able to use OBJ or FBX formats which will be converted into SFA or SFB format, which will be interpreted by ARCore and Sceneform. But unfortunately, this is broken since Android Studio 3.6, so you cannot import OBJ and the FBX formats if you are on this version, but you can use it. You can import some assets using the Android Studio 3.5 and something. So where you can find some nice 3D assets, you can find it on Sketchfab, which is a very great platform. You can buy or can find them for free using Poly from Google, using TurboSquid, or using the Unity Asset Store. Or if you want, you can also build your own 3D assets if you want to, using Maya, Modo, or I don't know, 3ds Max, or Blender. Just before going forward, Google provides a nice web feature. You can test your GLTL file online, and this will assure your 3D asset is fine for your IR application. It's a great tool. So before Sceneform 1.16, this was added to your Gradle file when importing new assets. For example, your ship object. There is a Sceneform reference in Gradle. So on the Android plugin looks like this. So you have within Android Studio with the Sceneform Android Studio plugin, you will have a nice overview of your 3D object, which were very useful when placing your object or seeing what it looks like. So loading a complex 3D object is very, very easy. You can provide you XFV format using just the name of the file, or you can do it remotely or locally using GLTF, especially if you want to use the latest Sceneform library. You can remotely download your GLTF assets, not having it on your Android project, which will be at the end, if you have a lot of assets, it's going to be like a very huge application. Then with complex with 3D assets, you also can use Object Animator, as your 3D asset will be a node. Object Animator here will be mostly for translation, rotation, scaling. And before Sceneform, the latest version, the SBX format was the only supported format for animations. So there were some embedded animation with the format. From Sceneform from the latest version of Sceneform, you can use GLTF animation, which is not available in the 1.15 and below. So that's quite very interesting to use the GLTF GFTL animation on the latest Sceneform, thanks to the filament library. So here's how we can manage animations with your 3D assets. With the latest version, we are using the GLTF animator stuff. It's quite easy to get the instance, the animation instance, and then apply the animation you want, and play it whenever you want. Also for the previous version of Sceneform, same thing. You can check or get your animation by the data name, or parsing all the animation of the renderable, that just need to start the animation whenever you want. That's it. You're like all set for building awesome AR application on your own. But I want to talk a bit more about ARCore. So with ARCore, there's also some very nice feature. There's also augmented images, augmented faces, and cloud encores. So augmented imaging, like, is to bring augmented reality to like a classic image. To a classic image, you can use it without Sceneform. And ARCore can store up to 1,000 images reference per image database. So you're providing an image database where Sceneform will look at when looking at the real world, to see the match images you want to render, like you want to augment. For this image database, there is a nice tool called ARCore EMG. It's a command line tool. It's here to build the image reference database. So you just need to pass all the PNG you want without a lot of compression for better matching. But that's it. You can like play with augmented images. Also, you can play with augmented faces. Sure, everybody here at least try one filter on Facebook, Messenger, or Snapchat, or something like that. It's nice, it's stupid, it's good. There is a lot of fun playing with this, and you can have a lot of fun using this feature. It's quite easy to use. Also, there is an awesome feature called the Cloud Anchor. So all the data from the anchor will be stored in the cloud and shared between the users. So this is the AR collaborative stuff. So you can do multiplayer AR games, like if, for example, you can do like a beer pong game, or no, you can play ping pong or something like that. And you can use Firebase to share the Cloud Anchor to your users, or if you don't have the Play services on your devices, just implement your own solution for storing this data. Now let's talk a bit to finish a bit about AR on Unity. Unity is a powerful game engine. So you can build AR, VR, 2D and 3D games or 3D app. This is a nice and powerful game engine because it's cross-platform, so you can develop for Android, iOS, Windows, PlayStation, and so on. And also you can do applications and modules for Android. Right? And the interesting here is if your app does not need AR or all the time, now Unity introduced Unity as a library. And that's a powerful tool. You can bring the awesome experience of building Unity games and application into your Android apps without any pain and without any hack. So it's available from the Unity version 2019.3. You can add directly the Unity content to your integration, and it's a proper library integration. So here you have a very complex and very realistic game or very realistic experience in your Android app. So the old structure, Unity can export a project into a Gradle Android Studio understanding thing. So it's a Gradle project. Before that, if you are not exporting it as a library, it was like a standalone application. If you add it to your current Android application, it was quite hacky. The Unity engine won't stop very well. Your app will crashes. But now with the Unity as a library solution, it's all clear. So you have your games as a real dependency, a real library, and it works perfectly. Once overriding your Unity application, you can also send messaging to the Unity engine. So if you want to change the color of something in your scene, in your Unity scene, you can use the Unity message. But there is some limitation using Unity as a library. It's only a full screen rendering, so you cannot add it in the part of your views or add any layout. It's only one instance of the Unity runtime, only one at a time. So if you want to go for one experience for that, you have to play it with only one Unity runtime at a time. And sometimes you may need to change some code which is in your Android asset. So if you want to know more about Unity as a library, it's very powerful, and so you don't need any knowledge of that from an Android developer part. There is some nice blog post and a very cool example from Unity. And if you want to know more about AR in general and ARCore, so you can go on the developer documentation from Google. You can play with the code labs provided by Google. There is some awesome guidelines if you want to design or like build something on your own, build your own experiences. And also, I open source the code for the ship AR thing is available on my GitHub. So feel free to fork it, to play with it, to do anything you want with the code. So thank you very much. I'll be very happy to answer all your questions about ARCore and Sceneform, and I hope you had some fun, and I hope you will have some fun with some AR stuff. So as you've shown, a lot of things are changing, evolving, some things are broken. Is it safe to create a production app ready today? I fear I have to rewrite it. Yeah, you can definitely do some production ready application using the Sceneform 1.15. You may have some problem if you upgrade the Sceneform library. So there is no improvement with the latest version, so you can stick it to the latest version. Can we share the year between Android and I think so, because ARCore can deal with the ARKit stuff. So I think we can use GLTF assets between Android and iOS. I'm not very sure, but I think you can. How to debug a scene? That's a good question. Well, how to debug a scene, for example, so you can definitely use Unity to like add your assets and see what it looks like. If you have some issues with some position scanning and stuff, but you can also use the web page Google provide for validating your GLTF assets. So it will be like the first step, like to debug something with your 3D asset on your scene, and just to debug scene after it's like just some testing. Just place your assets on the scene and see what's wrong or what's okay. Is there any way to get GLTF file from Collab or over free? I don't know. I really don't know about that question. I don't want to give a wrong answer. So I think it's good. Maybe available on Slack or one-to-one if you want to. From 3 to 6 today. Creation, motion layout to animate object. Good question. I did not give a try to that, but I think I'll try it. Thank you for listening, for being there, and have fun with ARCore.